Right, so the last thing we're going to take a look at are properties of compounds. And this is taking really kind of everything that we've put together to this point on whether or not a molecule is polar or nonpolar and how that's going to have an impact on its overall chemical and physical properties. Okay, so for ionic compounds in general, so I'm going to follow this first column first. So for ionic compounds in general, well, not in general, always. Ionic compounds are always going to be solids at room temperature. And this has everything to do with the way that those ions are bonded to each other. They are going to tend to have high melting points and high boiling points. And again, it's going to take a lot of energy to pull those ions apart from each other. And because they are ions, they are going to be very, very good conductors of electricity in an aqueous solution. In order for electricity to move, and electricity is essentially a flow of electrons, you need to have these positive and negative ions in order for those electrons to flow. Covalent compounds are going to be all over the map as far as states of matter go. They could be solids, liquids, or gases, and it's going to depend on whether or not they're nonpolar. Nonpolar molecules, as we'll see in a little bit, are going to have very weak interactions with each other, so they're going to tend to be gases. Whereas solids and liquids are going to tend to be more polar molecules where they're going to have those overall dipole moments which allow them to interact with each other a little bit better. Covalent compounds in general are going to have low melting points and boiling points, and because there are no ions, there are no charges, they are not going to conduct electricity. Okay, this is taking everything that we have learned in the last few chapters and kind of putting this together. And if it were me, I would definitely print this out or write this out so that I would have this as a study guide for myself as I'm going through figuring out whether or not I'm dealing with an ionic compound or a covalent compound. So first, let's talk about the differences in terms of naming. For ionic compounds, we are not using prefixes. There's no need to tell anybody how many of each ion you have. For covalent compounds, it's very important that we tell everyone exactly how many of each atom we have, so prefixes are used in covalent compounds. Now, for both ionic compounds and covalent compounds, we're changing the ending of the last element to IDE. As far as the elements that are involved, for ionic compounds, these are going to be the interaction, the bonding between metals and nonmetals. And for covalent compounds, it's going to be between nonmetals only. The bonding for an ionic compound involves a transfer of electrons. And for covalent compounds, it is a sharing of electrons. So again, this is really useful, kind of a refresher on how to go about naming, what's involved, and how those bonds are different. So again, I highly recommend you either write this down or put this on your note card or something. It's going to help you remember the difference between these.